In this video, we're going to be looking at scientific notation. In 1, it says, we know that 3.2 times 10,000 is equal to 32,000. Using exponential notation, 10,000 can be written as 10 to the fourth. So we can write 3.2 times 10 to the fourth is equal to 32,000. What is the relationship between the exponent and the number of decimal places moved? So to turn 3.2 times 10,000 equals 32,000, we would have had 3.2 and we would have moved the decimal place 1, 2, 3, 4 times. So we move the decimal 4 units to the right. In 2, it says we know that 3.2 times 0.0001 is equal to 0.00032, noting that 0.0001 is equal to 1 over 10,000, or 1 over 10 to the fourth, which is also equal to 10 to the negative fourth. The expression can be written as 3.2 times 10 to the negative fourth, and then it wants to know what is the relationship between the exponent and the number of places the decimal moved. And if we started off at 3.2, we moved it 1, 2, 3, 4 units to the left. So we moved the decimal 4 units to the left. In 3, it says write each number in scientific notation. And it's important to remember that when you're writing it in scientific notation, we're going to write it in the form of k times 10 to the n. The absolute value of k needs to be between 1 and 10. So if we have 623, we can write that as 6.23, so that our number is in between 1 and 10. And then we move the decimal place 2 spaces to the left. So we're going to have times 10 squared. 10 squared is equal to 100, and 100 times 6.23 is equal to 623. In B, we have negative 0.0000461. So we're going to have negative 4.61 times 10, and then we need to count how many decimal places we moved. So we would move 1, 2, 3, 4, 5. So times 10 to the negative fifth. C is 2 times 10 to the fourth raised to the fourth. So that's going to be the same as 2 to the fourth times 10 to the 16th. And 2 to the fourth is equal to 16. So we have 16 times 10 to the 16th. And we need to move our decimal place 1 unit so that we have 1.6 times 10. And if we moved it 1 unit, we would need to add 1 to our exponent and have 17 instead of 16. In D, we have 3 times 10 to the third times 4 times 10 to the negative fourth. And we can write that as 3 times 4 times 10 to the third times 10 to the negative fourth. And this is equal to 12 times 10 to the negative 1. And now we need to turn 12 into 1.2. So we have 1.2 times 10 to the 0. And 10 to the 0 is equal to 1. So this is just going to be equal to 1.2. In 4, it says, in theory, there are 1 times 10 to the 9th possible Social Security numbers. If the population of the U.S. is about 3 times 10 to the 8th, how many Social Security numbers are available for each person? So we have 1 times 10 to the 9th divided by 3 times 10 to the 8th. And we can rewrite this as 10 times 10 to the 8th divided by 3 times 10 to the 8th. And now our 10 to the 8ths are going to cancel. 10 to the 8th over 10 to the 8th is equal to 1. So we're left with 10 over 3, which is equal to 3 1/3. So we could say that there's 3 Social Securities per person in the United States. And that's our video on scientific notation.